Last lecture we had gone through details of convolution. We had decided how to actually compute convolution, and also we could formulate the same in the mathematical terms. Convolution happens to be the major operation as regards to the subject signals and systems, or as regards to discrete time signal processing. This convolution sum for discrete signals, it happens to be a convolution sum, whereas for continuous signal it happens to be a convolution integral. To that convolution integral we will come after some time, but in today's or maybe in one or two sessions I would like to see that a very strong base is created about the discrete systems. I suppose that when the things go live, your class would like to create a good impression that the class is disciplined and does not create undue disturbance. So in general, what we can conclude is that we have a sequence as input, one more sequence as system, and the convolution of these sequences results into another sequence, which is the output. So that completes this study of what we can say the system. So a sequence of input signal, one more sequence which operates on the input sequence, and that operation is a convolution operation, and result is the another sequence. So output sequence is convolution of input sequence and the system function. And for that purpose, what we have also discussed further is a special class of signals, that is the unit impulse, that is delta n. The sequence delta n we had considered. So when we look only towards the output, that output emerges from a system to which some input has been applied. So merely looking at the output we cannot comment. Merely looking at the output we cannot comment from what system it has come. Are you getting me now? Let us understand the concept of impulse function, how it is significant and so. We are having these sparrows also want that their sound should go live. So Yn is an output sequence, Xn is an input sequence, and Hn is a system function. Yn is an output sequence, Xn is an input sequence, and Hn is a system function. Then Yn is a special combination. Convolution we can consider to be a special combination of Xn and Hn. So merely by looking at Yn, you cannot comment from what system it has come or from what input it has come. It's a combination of these two. So it is likely that there would be two separate systems which will receive two different inputs and still may result into same output. Right? Because it's a combination. Just what we can say, if it is given that x plus y is equal to 8, you can't comment what is x and what is y. Because 8 can be either 4 plus 4 or 3 plus 5. Then, if we introduce one special function as impulse function, delta n. What is the property of impulse function? that convolution of impulse function with any other function is that other function. Impulse function, that is delta n. What is the property of delta n? Delta n is equal to 0 when n is other than 0, and delta n is equal to 1 when n is 0. So delta n is a special sequence called an impulse function which has got a value of 1 at n equal to 0 and 0 elsewhere. It is also called a unit impulse because it has got a value of 1. If it has got a value of 2, then it will be impulse. It is called as impulse of 2. In that case, the other function gets multiplied by 2. So delta n is a function which, when convolved with any other function, the outcome is that function itself. So what we can say, if you convolve any sequence with an impulse function, then the output is the same sequence. So if you want, if this is unknown to you, it is not known to you, then if you apply impulse as input, what is available in the output is Hn itself. Or if you make Hn to be impulse, in that case whatever is input comes at the output. So convolution with impulse is the function itself. Convolution with the impulse is the original sequence itself. Right? So impulse is a special class of functions. Is it clear now? Then the output is computed using convolution. Output is computed using convolution. In that process, this xn may be infinitely long, means it may be real time. Real time in the sense what? There may be a continuous function which is being sampled and values are, means suppose if temperature of a patient is the signal, then at every second I will measure the temperature, means x t of 0, t of 1, t of 2, so that will become a sequence, right? So input can be a real-time sequence, it will proceed continuously. This Hn is also a sequence which is having a value 0 for n less than 0, and which may have finite values after n from n equal to 0, 1, 2 and so on. So mirroring the Hn and shifting it. Mirroring Hn and shifting it is a technique with which we can compute entire Yn. But if Hn is too long, in that case it becomes difficult to compute Yn because the computation becomes too long. Then if we had got Hn as a deterministic function, in that case it is possible to convert the convolution expression which contains infinite term. Remember, output is always convolution of input and system function. Then if system function means the output sequence is always a convolution of input sequence and system sequence. If the system sequence is infinitely long, in that case what happens is that to compute every term of the output you need to carry out infinite computations which may not be possible. Therefore, it is possible to express the same infinite term convolution sum into a finite expression which consists of some constants that multiply few previous inputs and some other constants that multiply few previous outputs. Some constant may multiply current input also. So in a recursive equation, it is possible to fit in the infinitely long sequence Hn can be formulated and can be represented into a finite term equation using recursion. So usually what we have got means, ideally every Yn is summation of k equal to 0 to infinity h of k x of n minus k. But practically what we have got, practically can you write the equation? Practically it is again, let us say k equal to 0 till some capital M minus 1. So previous M samples, total M samples, this will change as
M minus 1
bk x n minus k plus k equal to 1 to say capital N minus 1 ak y n minus k. That's all. So with this yn this is a working formula, working equation for any system in general. So these either Hn or these coefficients AKs and BKs, these coefficients AKs and BKs describe the system. The coefficients AKs and BKs describe the system.
तीन मिनट आहे पॉज केलंस ना.
So the second section involves with the study of these systems, input, system and output. So system transforms the input, or system changes some properties of the input and results into output. So in what way, means it is just like a student which enters to the college in the first year and passes out from the college in the final year. So he changes some attributes when he has come to the college, and when he leaves the college, some attributes of an individual get changed. And what change is brought in by the system, then again the final product depends upon what were the original attributes and what changes are brought by the system. So two students going through the same system will behave differently, or two similar students going through different systems will behave differently. So it is the system which changes some attributes of the input. So what are the attributes of the input? In what way it is to be studied? In what way it is to be formulated? There are concepts like the transform, Fourier transform concept is there, then discrete time Fourier transform is there, then discrete Fourier transform is there, and then Z transform is there. So all these are trying to represent the same input sequence in different manner. Sequence itself is one representation. Sequence itself, that is xn, means for every value of n I know xn. So sequence itself is one representation. Other than that, there can be an alternative way to represent this xn itself. There can be an alternative way to represent this xn itself, that is called as transform. That is called as transform. So at the initial stage itself, I would like to clarify that this transform is somewhat complex in nature to understand. So it is expected that every individual will try to spare the attention to the maximum capability of an individual, and after that also there would be some instances where you may go completely blank and not able to understand. Then for that purpose, these recordings it is hoped that these recordings will come at your rescue. As I had already stated, we have deliberately chosen the second section, introduction, first, so that it is somewhat simple to understand. Rather than going with the classical approach of defining first and presenting it in such a manner that it should not be understood, we try to present it in a manner in which one can understand and then try to go to the definition. So I am sure that now you have got a complete idea of an input sequence, a system represented by a sequence, and an output sequence. That's all. So the study is now confined to the study of sequences. Study of signals and systems as regards to second section is confined to the study of sequences. What properties one can look at the sequences, and we shall proceed further. So transform is a way of alternate representation of a signal, of a sequence. So I hope now everything is clear. Xn, Hn and Yn, two sequences convolve themselves into a third sequence. So the concept of sequence is clear, concept of convolution is clear, study of a special sequence like impulse function, impulse sequence is clear. And now the system brings about changes in the input sequence which results into an output sequence. Then we want to study what kind of changes it brings about, what are the ways in which one can study the systems, and for that purpose we have to study the sequences in detail. So let us try to have a study of sequence. So sequence is basically a stream of numbers. Everybody agrees upon. Sequence is a stream of numbers or array of numbers. Sequence is an array of real numbers for the time being, let us say. Sequence is an array of real numbers. So we are now concentrating ourselves on the concept of x of n, where n is an index which is an integer and xn is the value of the sequence at a particular given integer. Means a sequence is a table in which the first is index number, serial number, and the second is the value. As you have got index in your notebook, I hope you are not at all aware about the index page in the notebook because you never look at it. So a serial number is there and contains. Similarly, the sequence is just like that array where the index and value. Index is integer and value can be real. Now, number one is that a very simple classification. The sequence can be finite or infinite. Means it is valid only for a finite duration or it is valid for infinite duration. The index may be negative or index can be only 0 and positive. Is it clear? So just for now our focus now is study of sequences, because we have come to a conclusion that it is only sequences that matter in discrete time signal processing, where input as well as system and output are sequences only. So how sequence is to be studied, that we are now looking at. So finite sequences, infinite sequences, single-sided sequences, double-sided sequences. Then there may be one who thinks in an eccentric manner may say, I have a sequence which is valid only up to 0 and doesn't exist after 0. That is an extremist view. Even though it's a perfectly scientific view, but a normal person doesn't have these things in his mind. So finite length, infinite length, single-sided, double-sided. These are different ways. Then deterministic and non-deterministic. Deterministic means the sequence is, let us say, infinite sequence, is an array of numbers, and to represent the sequence completely, we must represent its all values. To know xn, when I can say I know xn? I can say that I know xn when I am able to know, or when I find all values of xn for all n's. Values of xn for all n's. So, if it is possible to represent xn by using a formula, in that case it becomes a deterministic sequence. For example, xn is equal, let us consider, for time being, let us consider only single-sided sequences, positive side sequences, and means xn is equal to 0 for n less than 0. Let us say xn is equal to 0 for n less than 0, number 1, and then we can have xn is equal to half raised to n for n greater than or equal to 0. xn is equal to half raised to n for n greater than or equal to 0. So what we mean by it? Means in this case, with these two equations only, you are now knowing xn completely. You are now knowing xn completely, right? Now there is no ambiguity about knowing xn. Means xn contains how many terms? Infinite terms. But to represent infinite terms, there is no need now to have all those values written separately. By a single formula, you are able to represent. We can also take another one. We may have both sided sequence. So xn is equal to half raised to mod n. Xn is equal to half raised to mod n. How that sequence will look like? Is it okay? That sequence will look like 1 at n equal to 0, half at n equal to 1 and minus 1. 1/4 at n equal to 2 and n equal to minus 2, like that. Okay. Mod n is, you see some problem? Because if we don't put mod n, what will happen? It will become infinite when n goes to minus infinity. It will become infinite when n goes to minus infinity. So as to keep it range bound, so as to have a bounded input, I will just put mod n. Right? Then 1 may come up.
माइनस मध्ये कसं जाईल ते एका साईडला पॉझिटिव्ह जाणार ना माझ्या तर असं की मॉड आहे त्यामुळे प्लसच जाणार दोन्ही साईडला कसं एका साईडला एनची व्हॅल्यू निगेटिव्ह आहे रे अरे एनची व्हॅल्यू निगेटिव्ह आहे काय आहे हाफ इज टू एन आहे मॉड एनची व्हॅल्यू मायनस वन जरी झाला
xn इक्वल टू sin n. Right? So in that case also, it is known fully. this case, I have represented using two terms. I represented using two terms. And I may have xn is 2 raised to n. For n, now what is happening here? It becomes a finite length sequence. It is non-zero only for a range and 0 elsewhere. So x0 is 1, x1 is 2, x2 is 4, x3 is 8, likewise x7 is 128. That's all. x8 is 0 again. x8 is 0. Right? Is it okay?
Jadi ikuis lagi bagus lah.
xn is equal to 2 raised to n modulo 8. What do you understand by this? N modulo 8.
Percentage.
So percent is a symbol. So to understand it more clearly, n modulo 8. What does it mean? So if n is 0, this n modulo 8 is 0. N is 1, n modulo is 1. N is 7, n modulo is 7. And n is 8,
0.
it is 0. N is 9, 1. And n is minus 1. N is minus 1, what it is? When n is minus 1, what n modulo 8 is? When n is minus 1, what is n modulo 8?
Minus 1. Minus 1.
Is minus 1? No. Correct? Okay. So, minus 1 modulo 8 is 7. Minus 1 modulo 8 is 7. So, the concept of modulo 8 is, if the thing is very simple, when we go for modular division, it is modulo 8. So, if n is between 0 to 7, then nothing is to be done. N modulo 8 is the number itself. If n is between 0 to 7, then n modulo 8 is number itself. If n is more than or equal to 8, in that case 8 is to be subtracted till the subtraction becomes falls within 0 to 7. If n is less than 0, then 8 are to be added till the addition falls in the range 0 to 7. So this becomes a repetitive signal with a periodicity of 8, or a periodic signal. This becomes a periodic sequence with a period of 8. Now, another signal, another sequence. another sequence. Xn is equal to sine pi n by 8. Xn is sine pi n by 8. So what happens there? For a sine function, it is periodic for a period of 2 pi. It is periodic for a period of 2 pi. So when pi n becomes pi n by 8, it has to become 2 pi. When pi n by 8 becomes 2 pi,
16.
it goes cancel. So it is a periodic with periodicity of 16. This becomes a periodic sequence with a period of 16. So whatever is the value at n equal to 0, same will come at n equal to 16. Because sine function itself is a periodic function. 2 raised to 4 is not a periodic function. So periodicity will not be automatically introduced. Periodicity will not be automatically introduced. Is it clear? So finite length, infinite length, single sided, double sided, periodic, aperiodic.
Gitu aja. Jorong berangkat. Sudah. Jorong setengah. Tadi kan aja. Tadi kan. Itu berani kayak gitu juga ban. Ada aja gitu ya. Sangat gede kan pasti.
So let us have xn is to 1, 2, 4, 3 as a sequence. Xn is 1, 2, 4, 3 is a 4-point sequence. X. You are thinking of some other sequence? So Xn is 1, 2, 4, 3. X0 is 1, X1 is 2, X2 is 4, and X3 is 3. Is a sequence. So here a very simple common sense conclusion we can draw is that if my sequence is a limited sequence, a finite sequence, in that case I should not stress much on finding a formula which represents that sequence. But because I can represent it using the values also. But if my sequence is infinite, in that case I must try to put it into some formula, otherwise I can't represent it. So it's a 4-point sequence represented by the points themselves. Xn is 1, 2, 4, 3. Now, without biasing you about any kind of complex terminologies, we try to have, anyway you are learning linear algebra, in which matrix you must be aware about. So just one calculation process we will implement, and that process we can find, that it is possible to represent this sequence in an alternative way. So let us say that Xn is the original sequence, which is represented by 4 points. So I need 4 points, 4 values to represent original sequence xn. Now, if I decide to have, say, yn, or for that matter, let us say yn, or we may have x dash n also, which is in which I claim to transform xn, Number 1, will it be possible for me to transform these 4 points into a single point? The answer is yes. I can represent. So what I have? A sequence of 4 points, 4 values, x0, x1, x2, x3. Now if I say that I would like to represent them using a single term, then I can say sum of x as that term, and that I will represent 1 plus 2 is 3 plus 4 is 7 plus 3 is 10. Sum of 10. Sum is 10. So I had 4 points. I had a 4-point sequence, 1, 2, 4, 3. I transformed that sequence into a single term, which is their summation. Is it correct? This is a transform. Whenever I use the values in the original sequence and with some formula I compute some another value, that is a transformation. But now given xn, you can compute sum. Is it okay? But given sum, can you compute xn back? Given sum, you can't compute xn back. So this summation transformation is non-invertible. It can't be inverted, means it can't be reversed. From xn you can compute sum, but from sum you can't compute xn. We will take a further small look. Let us have only 2-point sequence. 1 and 2. Okay, 4 point is small, but we can have a further small 2-point sequence. Then I can have sum. What is sum? 3. Sum is 3. Is it again invertible? No. From 3 I can go back to 1 and 2. But I perform one more operation and I have one more as difference, diff, 1 minus 2. Or I change the sequence itself, so it makes it more simple. Whatever the sequence. So sum is 3 and diff is 1. Sum is 3 and diff is 1. Now there are 2 ways. One is original xn as it is 2 and 1. I have represented. Now if I say that a 2-point sequence xn is now transformed into a 2-value array in which first represents the sum and second represents the difference, then by using these 2 values, can you find the original values back?
Yes.
How?
X and Y simultaneously.
So now what we have got? So I don't use xn. So I will not complicate. I will use x0 and x1. So x0 is equal to 2, x1 is equal to 1 and 0 elsewhere. So this is the original representation. And this I have transformed into sum, which I also make it small, as sum is equal to 3 and difference is equal to 1. So S is equal to x0 plus x1 and D is equal to x0 minus x1. And naturally, I know that if from x0 and x1 I can find S and D, in that case what can I do? If I add these two equations, what I get? S plus D is equal to 2x0, or x0 equal to x plus D by 2. And if I subtract the second equation from the first, what I get? S minus D is equal to 2x1. And thus the transformation has become invertible. Thus the transformation has become invertible. So what happens is, my perception is that we study transform after defining it in complex words, say Fourier transform, Laplace transform, then Z transform, then there is, don't make fun of these transforms. Then there is some discrete cosine transform and like that. So because those are defined in complex terms, a phobia about transform is created. Therefore, in general, what is the best definition of transform? Transform is an alternative representation of original information. Transform is an alternative representation of original information. Transform is should not be necessarily invertible. So Précis writing is a transform. I am sure that you must be knowing Précis writing into one, right? In the language study, a paragraph is given and you are supposed to have a 1/3 of its Précis, means hoping that most of you have come from convent and still not able to understand the meaning of Précis, let us use the native language. It is saransh. खालील परिच्छेदाचा 1/3 सारांश लिहा. So Précis writing, Précis is a transformation. From the paragraph you can convert to Précis, but not vice versa. But still it's a meaningful transformation, because even if it is not invertible, the information in original paragraph was including some redundancy. It is transformed into a small one without disturbing much meaning of it. So invertibility is not a necessary thing for transformation. There may be some transforms which are invertible, there may be some transforms which may not be invertible. If the transform is invertible, in that case we can reconstruct from original transform, and there exists an inverse transform. There exists. So these are the transform equations and these are the inverse transform equations. The same can be put into matrix. How can you put into matrix? With the linear algebra background much clear to you. S and D is a column matrix. There must be a square matrix, and x0 and x1 another column matrix.
Coefficients.
S is equal to x0 plus x1. That is 1 and 1, and D is equal to
1 minus 1.
So this is the matrix. So if you want to have from S and D, if you want this, then this is matrix A. So if you pre-multiply both by A inverse, so A inverse into this, A inverse into A, so it would be identity, so it would be x0 x1 only, identity into that column matrix. So
Into A.
So how is that S0? X0 is S plus B by 2. So half and half. and x1 is what? S minus d by 2. So half
minus
and
minus
so half S minus half. Is clear? So this is the inverse of this. Is it like that? Or if there may be some competition there, you can correct it. Is it okay? So this is the concept of transformation. So transform is very useful tool in analyzing the signal. So an alternative representation. So sum means the average. So we can design the terms of alternative representation so as to make them more meaningful. So signal as such exists in its original form. We can design the equations which compute different terms in the transformation in such a manner that the stress is given on that parameter which we mean more while designing the transform equation. So transform original signal terms are there, but the transform terms are designed in such a manner that they project a specific feature of interest to us. Transform does not add any new information in it. Transform is designed in such a manner that the terms in the transform exhibit the information in the original sequence in a more readable manner. So this is transformation. So with this background, I am sure that you would be able to deal with various transformation in an effective manner. Okay.